forward to what we take up today?
Yes, ma'am.
Happily, it's not so new. Part of it is old, but there's some new twist to it, okay? So when I say terms in algebra, what different terms are you familiar with? If it's just one term, then you say it's monomial, right?
Yes.
If it's two terms,
Binomial.
if it's three terms,
Trinomial.
it's many terms.
Polynomial.
Yes, that means you're ready. Today, we shall dig into a number of these terms. Like, for example, if we have binomials, then consistently we will be doing operations with binomials. If I say, for example, x plus y, right? That's a binomial, isn't it?
Yes.
Why is it a binomial?
Because it has two
It's
terms.
got two terms, x and y. If I say, for example, that, what does it tell me?
The square of the binomial.
It's the square of a binomial. Put this in language of algebra.
The cube of the binomial.
How do you do this?
The fourth root of the
The
binomial.
fourth power of a binomial. So here we have consistently an increasing power. What is power 1? Is there such a thing?
Yes.
Yes. If I have this, can I also write it as that?
Yes.
Yes, but I don't need to. When it's not there, it's assumed to be 1, right?
Yes.
So, if we expand this, what does it become?
X plus y.
Right? You remember your lessons. If I expand this,
X squared plus 2xy plus y squared.
right? Did you memorize those? Or you just understand? Okay.
X plus y.
In other words, what do we do with the exponents?
We add.
Lovely. So if you don't understand or you don't remember how to do it shorthand, cubing a binomial, you can always go back to the old method, right?
Yes.
If I go back to the old method, then it would look like so. I said, first, let's adapt the square. X squared plus 2xy plus y squared, and do it the long pen. Okay. And I said, multiply. What will this 2 give me?
X cubed.
And this one?
2x squared y.
And this?
Xy squared.
And then this?
X squared y.
Is there another way I can put it down rather than put it here? Is there a place where it belongs?
Yes, ma'am.
Where?
At the column of 2x
So
squared
they're
y.
similar. Might as well put them together. So now I multiply this 2, I have
X squared y.
And then I have this.
2xy squared.
2xy squared. Does it belong here?
Yes, ma'am.
And then this.
Y cubed.
Is there a way of simplifying this?
Yes, ma'am.
How did it go?
We add
Yes,
x cubed plus 3x squared y plus 3xy squared plus y cubed.
So now, how many terms does the expansion have?
4 terms.
Right. How many terms does the expansion of this have?
3 terms.
And the expansion of this?
2 terms.
Okay, now, is there a relationship between the expanded form and the power?
Yes.
What is that relationship? Alright, what will you expect as the number of terms here?
5.
5 terms. We'll find out how the 2 terms will be. 5 terms, right? Now, if we look at this very closely, I can easily give a rule. This doesn't have to take the expanded form of 1. Okay. So we look at this. The first term is the cube, and the last term is another cube. Did you notice that?
Yes.
How about the second term?
Square
We
of
say
the first term.
it's 3 times the square of the first term times the second, plus 3 times the first term.
Times the square of the second term.
Right?
Yes.
So there's a play of words. Is there anything else that you notice apart from the fact that these are 4 terms when that is cubed? And you get 3 terms when it is squared. How many terms would you expect when it's raised to 4 or 5?
5 terms.
Okay, so there's a kind of a hidden rule already. So in words, how do we say this? X cubed plus 3 times the square of the first term times the second, plus 3 times the first term times the square of the second. Okay? Alright, so you don't have to have an expanded form like that. Supposing now I have 2a plus b. What would be the expanded form if we say that means I cube the first term? How much would that give me? What's the cube of the first? This is the cube of the first.
8 cube.
8
Cube.
And the last term will be the cube of the second term.
B cube.
Now I know 2 of the 4 terms. So there should be no more fear getting the others, right?
Yes.
Except there's an element of 3. So 3 times
The square
square
of
of
the
this.
first.
How much is the square of this?
4a
3
squared.
times 3
12a squared.
plus the second.
12a squared b.
Lovely. And then the next term will be 3 times this times the square of this. How much is that going to be?
6a b squared.
A
B squared.
squared. We ran out of space. Let's bring it down. So it's kind of easy, right? It's really easy. There. Let's try another one. Supposing I have 5m plus 2b, and I cube that. Right? The first one.
125 m squared. M cube.
Alright. And
88 cube.
yeah, let's put it far off. And then the middle. This is where you can go. Done?
Yes.
Alright. So we said 3 times.
Square of that 75 m.
How is that?
75 m squared.
Times square. Times 2.
150 m squared b.
50.
B.
Plus. I move this. Okay. And I moved it. What's missing here? So I said 3 times this.
50 m. 40 m b. 60. 60.
Let's do it again, slowly. We say 3 times the first term plus the square of the second. What's the square of the second?
4b squared.
3 times 5? 3
50.
times 4?
60.
60.
M b squared.
Alright, that's a little bit. How many terms?
4 terms.
Right. Now let's see. What's the missing exponent here?
1.
And the missing exponent of them.
1.
And you notice anything about the exponents?
Yes.
What is it that you notice, Rich?
The exponent of every term is equal to 3.
Oh, 3, no more. 2 and 1. 1 and 2. 3. So it's easy to see whether you are making a mistake. Right?
Yes.
Let's move on forward. What is the way I can do this? If you say, Mom, it's like a ladder. As you progress upwards, you can use the previous step, right?
Yes.
So can I say this? X plus y cubed times x plus y. Would that be a good approach?
Yes.
Yes. What's another approach?
X plus y squared times x plus y squared.
Oh, you say, you forgot to say something. It's not x plus y squared, because if I heard you right, you said x plus y.
X plus y squared.
So last time we said language of algebra, but sometimes you can get very careless about it. Rather than x plus y squared, you say x plus y squared. Right? So you were saying to me, I could also get that this way. Then, right?
Yes.
Still the same. They just come in different costumes. Then we'll have a long skirt or a pair of pants, a blouse. The other one will just very ordinary, right? But let's find out if they lead to the same expanded form. That's one way. You cannot just accept what the teacher says. You have to verify. And we're going to verify that now. Let's expand this. Yes. Can you still see up to here? All right. What's the expanded form of this? It's right there. Right? It's right there. Now, even at the expense of wasting ink, I take it down. Are they exactly the same?
Yes.
Yes. All right. Now I will do long multiplication. Right? This.
X to Mom, it should be x plus squared.
Alright. The pen made a mistake. Right? Let's multiply this.
X to the fourth power.
And this.
3x cubed y.
And this.
3x squared y squared.
And this.
xy cubed.
Are we done?
Not yet.
We haven't done our part for that.
X cubed y.
Where do I put it?
Under 3x cubed.
And with this.
3x squared y squared.
Then I put it down below this?
Yes, ma'am.
Yes. And with this.
Mom, it should be 3x squared y squared.
Plus
Plus 4x cubed y. Plus 6x squared y squared. Plus 4xy cubed. Plus y to the fourth.
how many terms?
5 terms.
Was our prediction correct?
Yes.
Did we predict 5?
Yes.
Are you sure? We predicted 5, and 5 we got. Now, let's see if this will end up like that. Okay?